Let's find the 6 trig functions of angle theta. I think the first thing that I'll do is I'll clearly mark or identify the angle that we're starting from. That's this angle up top. That's really important because that angle, depending on where I'm at, is going to determine the names of the other sides of this triangle. For example, I know this side down here that's across from that angle is going to be the opposite side when I go to set up my ratios, and this side right here next to it is going to be the adjacent side. The third side then is going to be the hypotenuse, the longest side, or the side across from the right angle. I can see that I'm missing a side in this triangle, and so even before I set up ratios, it's important that I know all 3 sides. So since I have 2 sides of the right triangle, let's go ahead and do the Pythagorean theorem to find the third side. So 5 squared plus 12 squared, the 2 legs squared, has to be equal to the hypotenuse squared. So doing a little bit of algebra and math, I can go ahead and simplify this. So 25 plus 144 has to equal c squared. Adding those together and then taking a square root gets me a missing side, a missing hypotenuse of 13. Well, if that number did not come out to be a nice, neat integer like this, there's some other things I'd want to do, and we'll take a look at that in the next video. So I've got all 3 sides identified. So there are 3 trig ratios, or 3 trig functions we're already familiar with, and I've started my chart down here at the bottom, and that's the sine, cosine, and tangent. And you probably have heard of SOHCAHTOA as a way to remember what these ratios were. The SO part of SOHCAHTOA tells you the sine, S, is equal to the opposite side divided by the hypotenuse. So looking at my diagram, I can see that the opposite side from the angle is 12 and the hypotenuse is 13. So the sine of theta is equal to 12 over 13. All I want is the ratio in this case. Cosine is the k part of SOHCAHTOA. That's a over h, or the adjacent side over the hypotenuse. So that's going to be 5 over 13. And then finally, to find the tangent of theta, tangent is the TOA part of SOHCAHTOA. So the tangent of an angle is equal to the opposite side over the adjacent. So in this case, that's going to be 12 over 5. So there's the 3 trig ratios you're probably already familiar with. The 3 new ones are reciprocals of these ones we already know. The reciprocal of sine is something called the cosecant, and its abbreviation is CSC. So the cosecant of theta, it's just the reciprocal of the sine ratio, so just take your fraction and flip it around. So the cosecant of theta is going to be 13 over 12. Next up is the cosine. The reciprocal of cosine is something called secant. That abbreviation is SEC. So again, the secant of theta is just the reciprocal of the cosine. So 13 over 5. And finally, our 6th trig ratio, our 3rd new one, the reciprocal of tangent is something called cotangent, and that abbreviation is COT. So the cotangent of theta is equal to the reciprocal of the tangent, so 5 over 12. So there are your 6 trig ratios for this right triangle.